Hello students, this is AMOL INGOLE, and in this video I'm going to explain what are generator sequences or also called as impulse responses in convolution encoder. Let us begin. The convolution code can be described by generator sequences G1, G2, G3, etc. These are the impulse responses for each n output branches in convolution encoder. Let us consider an encoder having k bit input and n bit output. We'll consider one example of a convolution encoder like this. If you see this convolution encoder, you will find that there are two outputs for this encoder, and there are three memory units. The generator sequences or impulse responses for this encoder can be written like this. For output 1, there will be one generator sequence. For output 2, that is V2, there will be another generator sequence. So if you have two outputs in an encoder, you will have two generator sequences. Let us see how to write those generator sequence from the encoder. If you see output 1 of this encoder, it can be derived by XORing the current message bit with the bit stored in M2 and with bit stored with M3. So by XORing these three, you will get output 1 of this encoder. The bit stored in M1 is not considered in XORing because there is no connection to this modulo 2 adder from M1. If you see output 2 of this encoder, the output V2 can be derived by XORing again the current message bit stored in M1, bit stored in M2, bit stored in M3. So by XORing these 4 bits, you can get output V2. So let's see how we can write the generator sequence. The generator sequence can be written like this. We are writing this for nth output. You can write in this way. So Gn0, Gn1 till Gnm. So there are 4 different bits that are XORed to get output 1 and 2. In the first one, the bit M1, the bit stored in M1 is not taken into consideration. Therefore, the generator sequence for this output 1 will be 1, 0, as M1 is not connected to modulo 2 adder, 1, 1. So the generator sequence can be written as 1011. This first bit is for the current message bit. This second bit is for the bit stored in M1, and it is written as 0 as there is no connection from M1 to the modulo 2 adder. And the third bit is for the bit stored in M2, and the fourth bit is for bit stored in M3. Similarly, you can write the generator sequence for output 2, and as this is a connection from the current message beat from M1, M2 and M3, so the generator sequence for output 2 can be written as all ones. Again, you can read in the same way. The first beat is for the current message beat, as it is 1. You can see there exists a connection from the current message beat to the modulo 2 adder, and the next 3 beats are for the memory units. You can also identify from the length of the generator sequence the number of memory units. We can now see one numerical based on generator sequence. So we'll consider the same numerical which we have discussed in our earlier video. The only difference is in that numerical, an encoder diagram was given, and now in this numerical, instead of an encoder diagram, the diagram is represented in the form of generator sequences. You can read this statement. Find the encoded output of the convolution encoder whose generator sequences are given as G1, and it is given as 1011, and the second generator sequence has all ones. You need to find the output till the memory reset to 0, and the input bit stream is given as 10111. So this is the same numerical. The only difference is this is in terms of generator sequences. So from the statement, you can actually find these things. The given encoder has memory units, and there are 3 in numbers. The memory units are 3 in numbers, and as I explained, you can identify it from the length of the generator sequence. The length of the generator sequence is 4. You will see that there are 4 bits in G1 and 4 bits in G2. So the length of the generator sequence is 4. Therefore, the number of memory units in this encoder will be 1 less. You can see here. This is M, which is number of memory units. So it is number of bits in the generator sequence, and there are 4 bits minus 1. So 0, 3. 3 will be the number of memory units. You can also identify from the generator sequence the number of outputs, as there are 2 sequences given, G1 and G2. That means the encoder has 2 outputs, V1 and V2. So you can identify the N, which is number of output bits from the generator sequence. And K will be number of input will be 1. So at any instant of time, only 1 bit will enter the circuit. From the generator sequence, you can also draw the encoder diagram, and the encoder diagram will be similar as we are discussing the same numerical which we discussed in earlier video. You can see here there are 3 memory units, and the generator sequence is given for the output 1 as 1, 0, 1, 1. For output 2, the generator sequence G2 is given as 1, 1, 1 and 1, all ones. If the circuit diagram has to be drawn like this, you can draw 4 memory units with 2 outputs. You can also show output V1 and V2 using the generator sequence. You can also write the output equation V1 and V2 using the generator sequence. So you can see here, this one is, the first bit is for the current memory bit. So you can write that as U. M1 is not considered. That's why 0 can be seen here. So you should not write that M1 in the equation. So XORing the current message bit, M2 bit, and the message, the bit stored in M3, you will get output V1. And output V2 can be obtained by XORing current message bit, bit stored in M1, bit stored in M2, and bit stored in M3. So by XORing all four, you will get output V2 for the current message bit. Thank you.